All right, so we are going to talk about hyperbolas. This will be our last conic section. Then we'll begin reviewing, and ultimately, you guys know what's going to happen. We will have a test. Now, you're going to see today some similarities and differences between hyperbolas and with ellipses. So I want to tell you right now that you really need to focus your mind so you can tell the difference, okay? Because they will not be the same as ellipses. It will be different. First off, just look at all of this going on. There's a lot happening. And I want you, if you can, focus only on the thing that's actually the hyperbola. Do you guys see the thing that's actually the hyperbola? Yes. It is the two red curves. You guys see these two red curves. Those are the actual hyperbolas. Everything else that you see is dotted lines. Why is it dotted? Because it's not actually there. Very good. Technically, it's not actually there. But why do we use it? Why do we have all those dotted lines there? What are they going to ultimately help us do? Plot the hyperbola. Okay, that's the ultimate goal here. So a couple of new things that you've never seen before. First off, we're going to still have vertices and covertices. So that's all good. We're still going to have vertices and covertices. What letter is associated with the vertices? What letter is associated with the vertices? A. A is associated with the vertices. What letter with the covertices? And what letter with the foci? All right, so none of that changes. All right, we'll talk a little bit later about how it's going to be different about how you know which one is which. But in terms of what letters you use to get all this stuff, it's still A, B, and C. Nothing has changed there. One thing that has changed, notice where your focus points are. Do you see how the foci are past the vertices? That's different. With ellipses, they were closer to the center, so that's a change. All right, which means, since that is a change, we have a new formula we're going to use. We have a new formula, which it's going to be c squared equals a squared plus b squared. All right? With ellipses, it was what? It was subtraction. Now it's going to be addition. The way that I remember it, and this is my preference, with ellipses, we had a plus in the middle of our equation. Or if you go back to the one that you did on the rewind, we always have what? Plus. So you think opposite, the c squared equals a squared minus b squared. Notice these are going to always have subtraction. So the opposite of that would be addition. If you don't remember, that's okay, because you will have a formula sheet for this test. All right, you will have a formula sheet for all this stuff. All right, not until May. You got plenty of time. All right, so now this is important. Now, because we have subtraction, sometimes we're going to have x come first, and sometimes y is going to come first. All right, now it matters. Now it matters, because subtraction is 4 minus 2 the same as 2 minus 4. No, so the order does matter. So you notice we're going to have sometimes we write x, sometimes we write y. The other thing that's going to change, a may not be the bigger number. A may not be the bigger number. Whatever one comes first is where you're going to get your A. Whatever one comes second, that's where you get your B. So we'll be talking about that. The last thing I want to point out is we have a few more new words. We have the transverse axis that connects your vertices. I always think of TV, transverse vertices, so TV. The other one is the conjugate axis that connects your covertices. Both of those start with C. That's how I remember that. Okay? So you will need to know those words and what they mean. All right, so with all this being said, let's try one. We want to take this information and write an equation. What am I always going to recommend, just like with ellipses? Make a sketch. So I'm going to make a sketch, x and y. My center, to keep it straightforward for the first couple of examples, is going to be 0, 0. Will it always be that way? No, but I'm going to keep it straightforward right now and just make it 0, 0. That is my center. All right, then it says a vertex point is where? 0, 12, which is up here. All right, so do you know where the other vertex point is? Very good, Megan. 0, negative 12. Now, at this point, I know what type of hyperbola it is. Why?
Because the two points up and down and the blue ones are left and right.
Well, so red points are my vertices. Whatever way your vertices go, that's the type of hyperbola. So since it's up and down, it's going to be vertical. So I'm just going to write that real quick, vertical. If it's vertical, what letter should we start with? If it's vertical, what letter should we start with?
B. No, C.
We should start with Y. Because the vertical direction is what letter? Is Y. All right? So I'm going to write Y squared. Why did I not need to write Y minus or plus anything? Because the center is 0, 0. So I'm going to write minus. What's going to come next? X squared. Very good. Both of these are going to have denominators. And it's going to be equal to 1. So that doesn't change. All right. The other thing it gives me is a focus point. Where is my focus point? 0, 20. So there's a focus point. Where's the other focus point? Very good. All right. So we can go ahead and write down what A is equal to. Do you know what A is equal to? Why? The distance from the center to a vertex is always letter A. And so that distance in this case is from the center to one of those vertices, so it will be 12. Now they also gave me what letter?
C.
It doesn't matter. We always use the positive because we're going to square it when we use it. They also gave us C. How do you know that, Adrian? Whenever they give you a focus point, they're also giving you letter C. That's the distance from the center to a focus point,
20.
which in this case is 20. Very good. So now I know that in my formula, I need to use which one of these? I need to use 12. But am I going to use 12? What am I going to do to it? I'm going to square it. Which way did we go for the 12? Did we go up and down or left and right? Up and down, which is with which axis?
Y.
The y-axis. So the y gets what in the bottom? 144. Yep, we went up and down 12. So 12 squared is 144. So now we need to find B, because B is going to go here. All right, B is going to go there. How are we going to find B? We're going to use that equation. And what is that equation? Great, so it's going to be different today. It is going to be addition with this equation. C squared equals A squared plus B squared. So what is C squared? Very good, Jeanette. 400. 20 squared is 400. Equals, what's A squared? 144. And we're trying to solve for B squared. So how would you get that?
You go backwards. 400 minus 144.
Which is?
256.
Very good, Rossi. Now, does anyone know what the square root of 256 is?
Yes, I do, sir. It's 18.
It's not.
16.
It's 16. And it's okay. We actually don't need it. I will write it down, but we actually don't need it because in the formula, we need what? We need B squared, which is 256. So guys, you should be freaking out right now. No? Why should you be freaking out? Well, the reason is what is A? A is our smallest number. B is bigger than A. That's different. All right? It's different. With ellipses, A was what? Always the bigger number. Now, in this case, A is always the one that comes first. A is the one that comes first. It can be bigger, but it doesn't have to be. All right? So there was an example of a vertical hyperbola. Now, we actually didn't even graph it yet, because we're going to do graphing later, but it would look where the curves were like this. Notice, which way are my curves opening? And upward. And what type of hyperbola is this? Vertical. So up and down is where your curves should be drawn. All right? Okay then, so let's do another example. Let's try this one. Always, 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 I'm going to recommend what? Draw a sketch. Now I'm keeping it straightforward to start. What is the center? 0, 0. All right, so there's our center, 0, 0. So now it tells us that the vertex is what? 8, 0. So because we're going left and right for our vertices, it's going to be a horizontal hyperbola. All right. Now we've already told everyone that it's horizontal, so what letter should I write first in my equation? Very good, x. So I'm going to write x squared over something minus y squared over something equals 1. Always be equal to 1, yes. It will be.
Why is it always equal to 1? Just because?
It's not just because, there is a reason. It's getting into an upper level that I don't want to take us there and confuse you. So can you wait until pre-calculus and then you'll discover why? Yes, you will. All right, excellent. Good luck in that class. So now we already have letter A. What is letter A? A is 8. But we're going to use 64 when we write it in the equation. And where does that go underneath?
X.
It goes underneath x. Because A always has to go first, or if you think we went left and right, which is in the x direction. Now they also gave us what point? A focus point at 10, 0. All right. What is letter C then? Oh, that kind of looks like a heart. Is it? Yeah. Yeah. Right there. Doesn't that look like a heart? Yeah. So what is C? 10. All right. So we're going to find B by using this formula again.
A is smaller than C.
Well, C will always be the biggest number. Well, you don't know. We haven't done B yet. What's C squared? 100 equals 64 plus, we don't know. Great. So is B actually big, or A actually bigger than B? Yes, it is this time. Because B is 6. All right. So what's going to go underneath y squared? 36. All right. Again, if I were to plot this, which we will do later together, it will be curves opening left and right. Why are they opening left and right? No, because it is horizontal, which means you're moving left and right. All right, so I'm going to give you guys about 10 minutes to try these 4 problems. You're just going to do the same thing we did, where you're writing the equation. All right, so your sketch doesn't need to be as beautiful, but I do want to see a sketch. And then we'll come back together and we'll try graphing them for the last 15 minutes. All right? All right, guys, go ahead and stand up and try these.